Okay, so we have this set of 4 vectors, and we want to find a basis for the linear span of these vectors. Okay, so there's basically 2 ways to do this. I'm going to do both of them. The way I do it first, I think, is the better method, just practically speaking, and I talked about that in a lecture. But I'm going to do it both ways, just because if you have more tools, you're better equipped. So the idea is that we want to row reduce the matrix that has whose columns are given by these vectors. So basically what we're doing is we're finding a basis for the column space of this matrix. But what is the column space of this matrix? It's just the linear span of those 4 vectors. Okay, so the first thing that we're going to do is we're going to subtract row 1 from row 2 and row 3. 1 minus 1 is 0, minus 1 is minus 2, 1 minus 3 is minus 2, 1 minus 5 is minus 4, 1 minus 1, 1 minus 1 is 0. Okay, 0 minus minus 1 is 1. 1 minus, whoops, I screwed that up. Okay, 0 minus 1 is minus 1. Come on. 0 minus 1 is minus 1. 1 minus 3 is minus 2. 1 minus 5 is minus 4. Okay, now I'm going to do the usual thing. I'm going to divide row 2 by minus 2. So it's going to be 1, 1, 2. That's what the new second row is going to be. One, 1, 2. And I'm also going to divide the third row by minus 1 or multiply by minus 1. So it's just going to be 1, 2, 4. Okay, so the next step in the row reduction process, I'm going to subtract row 2 from row 3. And so this is 1, 0, 0, 1. I don't know why I'm writing the columns first. Let me write the rows first. 1, 1, 3, 5, 0, 1, 1, 2. Now it's the third row minus the second row. 0 minus 0 is 0. 1 minus 1 is 0. 2 minus 1 is 1. 4 minus 2 is 2. Okay, so now this is in row echelon form, and we see that the pivot columns are the first, second, and third columns. So this means that a basis for the row space, or for the, a basis for these 4 vectors, the linear span of these 4 vectors, are the first 3 vectors. 1, 1, 1, 1, minus 1, 0, 3, 1, 1. Okay. So this is one basis for the linear span of these 3 vectors, and that was one method of doing. That was one method to find the columns, or to find a basis for the column space. Sorry, I'm so tongue-tied. This is my first video this morning, so we'll just have to deal with it. Okay, so now what we're going to do is we're going to, instead of finding the linear span of a basis for the linear span of these vectors. So notice how did we do it before? We put these 4 vectors into a matrix and found a basis for the column space of that matrix. Another way we can do it is put it into a matrix and find a row space, a basis for the row space of that matrix. So in other words, it's going to be like 1, 1, 1. So now we're going to put the vectors as rows. 1, 1, 1, 1, minus 1, 0, 3, 1, 1, 5, 1, 1. Okay, and so now we want to find a basis for the row space of this matrix. So the first thing that we're going to do, I'm going to subtract row 1 from row 2. 1 minus 1 is 0. Minus 1 is minus 2. 0 minus 1 is minus 1. Okay, now I'm going to subtract 3 times row 1 from row 3. So 3 minus 3 is 0. 1 minus 3 is minus 2. 1 minus 3 is minus 2. And now I'm going to subtract 5 times row 1 from row 4. So 5 minus 5 is 0. 1 minus 5 is minus 4. 1 minus 5 is minus 4. Okay, well now we can see what's going to happen. I'm going to do a few things, a few little cleanup things here. I'm going to divide the third row by minus 2. Actually, I'm going to divide the third row and the fourth row by minus 2. So that the third row becomes 1, 1. And I meant to say I'm going to divide the fourth row by minus 4, so that also becomes 1, 1. Okay, and now I'm going to subtract. Now I'm going to add where am I? Okay, I'm going to subtract or add 1/2 of row 2 to row 3. So this is 1, 1, 1, 0, minus 2, minus 1, 0 minus 1/2, or 0 plus 1/2 of 0 is 0, 1 plus 1/2 of minus 2 is 0. Okay, 1, so it's 1 plus 1/2 of minus 1. So it's 1 minus 1/2, so this is 1/2. And I'm going to do the same thing for row 3. So this is going to be 0, minus 2, 1/2. Okay, and then now I'm not going to rewrite everything. I'm just going to subtract row 2 from row 3. That entry is a 0. Holy cow. Let's hope the second video of the day is a little bit better. Okay, and now I'm going to subtract row 3 from row 4. And so now this is going to be 0. Okay, so a basis for the row space of this matrix is 1, 1, 1, 0, minus 2, minus 1. Of course, you can multiply that by minus 1 if you wanted to. And then 0, 0, 1/2. Okay, so that's the basis for the row space of this matrix. Now we just need to flip them back into column vectors so that they are a basis for the linear span of the 4 vectors that we're given. So this is 1, 1, 1, 0, minus 2, minus 1, 0, 0, 1/2. Okay, now let me just say as a passing comment, I think practically speaking, doing it the way I did it first, in other words, the method in the blue, is kind of the best way to do it, because you can use that same work to do things like find a basis for the row space of M, solve homogeneous equations, and that sort of thing. But doing it this way, finding a basis by looking at, making the vectors row vectors instead of column vectors and finding the row space, I like this method. One thing that's good about this method is that it's clear that these vectors are linearly independent because they have zeros in different spots. Okay, so there's no way that the 1, 1, 1 vector can be a linear combination of those other 2 vectors, because those other 2 vectors have zeros in the top entry, and the 1, 1, 1 vector does not have a 0 in the top entry. Okay, so for reasons like that, I kind of like to have the find the basis doing the basis of the row space method. Holy cow! Sorry about this, guys. Hopefully.